Hi everyone, and welcome to Big Data Made Simple. We know data engineering can seem complex, so our mission is to break it down for you. We're here to make learning about big data not just easy, but genuinely fun, especially if you're just starting out. Here, you'll find simple tutorials, real-world examples, and hands-on code demonstrations to help you master data concepts step by step. In today's video, we're tackling a fundamental tool, Apache Hive. We'll explore what it is, how its tables are structured, and the critical choice between managed or external tables. To give you a practical first look, consider this simple Hive query. It performs a common task, counting all error logs in your data. This single line of code gives you a crucial metric without writing complex programs. That's the real power of Hive. It simplifies big data analysis using a familiar SQL-like interface. Ready to dive in and see how it works? Let's get started. What is Hive? Hive is a data warehouse tool built on top of Hadoop. It lets you analyze and query large datasets in HDFS using SQL-like queries called HiveQL. The biggest advantage, you do not need to write complex Java MapReduce programs. Simple example. Instead of writing MapReduce to count errors, run SelectCount from logs where status =, error. Hive takes care of execution in the background and runs the necessary jobs on Hadoop. In Hive, all data is stored inside tables. Tables look like database tables but point to files in HDFS. There are two main types of tables, managed tables and external tables. Managed tables, Hive owns schema and data. External tables, Hive owns only schema, data stays in HDFS. Let's start with a practical example of creating a managed table, which is the default table type in Hive. Here is the SQL statement to create a table named Students. We define 3 columns, ID as an integer, name as a string, and marks as another integer. The clause tells Hive how to read the data files, specifying that fields are terminated by a comma. With a managed table, Hive takes full ownership. It controls the schema, the table's structure, and moves the actual data into its own warehouse directory. This tight control has a critical implication. If you execute a command, Hive permanently deletes both the schema and all the underlying data files. This behavior makes managed tables perfect for temporary data that only Hive needs to access. For example, if you're analyzing student test results for just one semester, a managed table is a great choice because cleanup is simple and automatic when you're done. Now let's see an example of an external table. Here is the code to create an external table called Employees. Notice the location clause, which tells Hive where the data lives in HDFS. In an external table, Hive controls only the schema, not the data. If you drop the table, the data remains in HDFS. Use external tables when your data is shared across applications or must not be deleted by Hive. For example, if you store employee records that are used by multiple teams or applications, an external table is the best choice. Let's look at a real-life example for a managed table. Say you need to analyze this month's sales for a temporary report. You create a table, do your analysis, and then drop it. Hive automatically deletes both the table's metadata and its data, making cleanup easy. For an external table, consider your master customer records in HDFS, shared across many reports and apps. If you drop the Hive table, only the metadata is removed. The actual data remains safe and untouched in HDFS, preventing accidental loss of critical information. Quick summary for freshers. Hive =SQL for big data. Managed table. Hive owns schema and data, deleted on drop. External table. Hive owns schema only. Data stays in HDFS. Choose managed if data is temporary. Choose external if data is business critical or shared. If you found this helpful, please like, share, and subscribe. Next video. Partitions, bucketing, and file types in Hive. Important for projects and interviews. Thanks for watching, and I'll see you in the next video.